Hello Kerbal, I'm Orbator, and as the title suggests, we are going to go to Jool. In fact, we're going to take a probe to Jool, because like any self-respecting space program, you'd want to send a scout out there first to see what is there before you go and risk a Kerbal's life. Anyway, in this tutorial, I'll be showing you how to get to Jool, but also how to build that rocket. But the first thing, the very important thing, and that is planning your journey. Also, there'll be bonus footage at the end, where I'll show you how to do flybys of multiple moons, or at least my attempt to, because it's the first time I've tried this. Anyway, let's get into the meat and potatoes, which is 2 websites that you can use for planning your spaceflight. First one you've got here is alexmoon.github. Make sure you select the right time frame, as you select in Kerbal now, and then you need to select Jool. Let's add a couple of notes because 100 kilometers on Jool is in the atmosphere. Set your departure date, the earliest time you want to leave, and plot it. This will give you what's called a pork chop plot, and it'll give you all this lovely information: departure, arrival, time of flight, even your total delta V, insertion burn delta V, and your ejection burn delta V that you're going to use to get away from Kerbal, and also some vectors. Now, this is all a bit complex. It may be a bit too much for you guys. There is an easier site called Olex, and let's take a look at that, shall we? Now, Olex has an easy to use interface. All you have to do is Kerbal, 100 kilometers start in orbit, Jool, do the maths. And it gives you all these lovely things like delta V, as well as these graphics of the Kerbal system, where the planets have to be, in these lovely pie charts. Anyway, this using Kerbal and Kerbal as an angle to plot against Jool, you get this angle, and that's the angle for the optimal burn when you have to go and transfer to Jool. So you can use this at any time. Make sure your ship is orbiting anti-clockwise. Then you can use the second graph of the direction that Kerbal is traveling, and it tell you when to start your burn, how many degrees from the direction that Kerbal is traveling. And this is awesome because it makes it a lot easier than this site. So whichever you want to use, there's also tools in Kerbal Space Program like Kerbal Engineer Redux, but you will get into them as we go along. So let's first start building our rocket. Okay, to start off, you need a guidance unit. I use the RC, I think it's 001S guidance unit, and now we need some kind of control. For this, to be able to rotate your probe and use less fuel, I suggest you use the reaction control wheel, and don't forget your fuel. Now, engine choice. Now, I go through all the engines, I use the small spark, I look at all that lovely delta V, but that's not the most efficient engine there. In fact, the LV909 is more efficient, whereas heavier, so you get less delta V from that. Now, you can experiment with other rocket engines, like perhaps the radial engines, but still not enough. So I go back to the Spark. Now, the Spark engine is a cool little engine in that it's low weight, even though it's got low thrust to weight ratio. Okay, now for power. I was going to use solar panels, but Jool is quite far out in the solar system, so they'll be less efficient. So use an RTG, a radio thermal generator isotope thingy-majiggy. Okay, and I suggest you use RCS on this build. I go ahead and put 2 on mine. You can get away with one of those tanks. This is where I use the offset tool to put the RCS tanks down so it's not so large. Anyway, next thing you want is a transmitter, an airtiner. Not only does it look like a probe now, it also, you can use this in career mode to transmit science data back to Kerbal. Okay, next on the list, I'm only adding this for show, but I'm going to add these radiators on the side to make it look a bit more like a probe, because we haven't got solar panels, but we can extend these out to make it look cool. Next, some batteries, just in case. Again, just for aesthetics. I don't think you need them, however, they might be handy when you're transmitting data back to Kerbal. Okay, RCS, and yeah, I had to move a couple of things around to get the RCS thrusters on the center of mass, and that is the tip here. You need it either on the center of mass, or you need a couple of thrusters at an equal distance from the center of mass. Anyway, this is our probe. Now the delta V has gone down, so what I think I'll do, I'll add an extra tank to that to get the delta V up. I want at least around about 2000 meters per second. Now you can go ahead and add extra tanks. I think that's close enough for my needs. But if you want to, take an RCS tank off or add extra fuel tanks to the build. For the transfer stage, I'm going to use the X200 fuel tank. You could use the larger fuel tank. Oh, and by the way, if you're using struts like I am here, attach them to the bottom part, then to the top. Otherwise, you get the extra weight of the struts on the probe itself. Little handy tip I just learned from doing this video. Okay, so that's our transfer stage with the Poodle engine layer on the bottom. Let's go ahead and put a fairing. By the way, someone asked me, is this a mod? No, this is not a mod. The fairings are stock to the game as of version 1. Okay, so I think we're ready to launch. All we need is a launch stage. So let's go ahead and do that. I'm assuming that you know your building skills. So let's go ahead and put an orange tank on here. I'm going to use the mainsail engine for the center tank, but we're going to add extra tanks to the external because we do not have enough delta V to get into orbit. Right, adding 2 decouplers on the side to add our booster rockets. Again, 2 more orange tanks. It's because I tested this out and this seemed the most efficient way to do it. Now I'm going to use fuel lines from the outer tanks to the center. That way we get enough delta V, and for the outer engines, use the skipper ones so you're not using too much thrust to weight ratio to get into orbit. You don't really need it. Okay, after adding struts to ensure that they do not flop around and some nose cones for the aerodynamics, we are ready to go. Oh yes, almost forgot. Just in case these ram our rockets on the once we decouple them, I put some Separatrons. Now a tip here, attach one, put it in the correct stage that you want when the decouplers are going to fire, and then use Alt and copy the part, attach them where you need them, and they go back into the exact stage that you took, copy the one from the stage out of. Therefore no restaging required. All we have to do is add some Rockomax launch enhancers. By the way, if you want extra control, you can add extra reaction wheels, larger versions, which I'm going to do by here. You can also add RCS to the large rocket, or you can add winglets. That's up to you. I'm going to leave that to you because I can get this into orbit with no problem. Let's name it now. Probing Jool. I couldn't think of a funny name, so we're sticking with that. Right, here we are on the launch pad, and this is the tool Kerbal Engine Redux. This is a mod, so I'm using a mod, you could say, but you can do this without a mod. This is just for information which you'd normally have. Now let's set Jool as our target, and as you can see on the mod, and if you do the angle thing, Kerbal, and Jool is out of angle. Okay, Kerbal needs to catch up to the Jool system so we get the correct angle, but also if you look on the Kerbal Engine Redux, we got the phase angle and the intercept angle. The intercept angle needs to be 0 when we're doing our burn, or at least close to 0. And before you go launching up into orbit, it's best to do the time fast forward thing while you're on the ground, because once you're in orbit, if you're at 100 kilometers, you can only fast forward time to 50 times normal speed, and everything is really slow. Trust me, one time I tried it, and it was taking forever for us to get our intercept angle. Okay, a quick fast forward in the video. I'm going to get the intercept angle to about 5 degrees. In hindsight, I would have done it to about 2 or 1 degree, then launched, and then planned the transfer burn. But 5 degrees I did it to, and you can see it 1 year, 179 days, and 4 minutes and whatnots. The whatnots are counted, of course. Okay, so let's go and launch. So I'm assuming you know how to launch a rocket? Of course you do. You're playing Kerbal Space Program. Anyway, if you haven't, go and watch a tutorial on how to launch. So let's launch. And off we go to the Jool system, or at least into orbit, so we can go into the Jool system. Now, little tips by here while launching: don't thrust too fast. If you get the white aerodynamic marks on your rocket, that means you're going too fast, so slow down your throttle. And always keep your rocket pointing on the nav pole close to the middle of the yellow dot. And there goes the boosters, but also while turning slowly over. Now, this is probably not the most efficient way to launch. I am by here. There are more efficient ways of launching, but I'll leave that up to you. That's the awesome thing of Kerbal Space Program, is that you learn by doing, as well as watching me playing it. Anyway, let's go do our orbit insertion burn, which you should also know by now. Now, I have to note, you don't have to be absolutely awesome at getting a circular orbit. Just get the best orbit you can, because you can adapt for that by using maneuver nodes on your transfer burn. Now, I suggest if you have extra fuel on your launch stage, don't decouple it by here like I have. Keep it handy because it's extra fuel. I think I dumped about 800 meters per second of fuel, which we could have used to go to Jool. Right, now for our plotting. Okay, a quick fast forward in time. You see, intercept angle is 0.79. I think about by here you can start to do your maneuver node to get towards Jool. But first off, let's zoom out, check where Jool is. You can see it's roughly about 90-ish degrees-ish. Anyway, let's line up curbing, and we knew that the angle was 114 degrees or so. So let's just plop down a maneuver node anywhere you want, around by here, around the angle you'd require, and let's go ahead. Pull on that prograde marker, and don't worry about the mun. I think I'm going to miss this, but keep an eye on it. If you're going to hit the mun on the way out towards Jool, then you may have to do slight alterations, or you could use the mun as a boost. It normally doesn't work that well though, because it requires more delta V to do course corrections in the future. Okay, so now you can see we've got the close approach markers, but no intercept. Now, doing little twiddles on the prograde and retrograde. No, you haven't got an intercept. A couple of things we can do. First off, we're not even on the same plane as Jool. So using the radial, try both if you have to try to get yourself on the same plane as Jool. Nope, still no intercept, but the close approach markers seem to be getting closer. Yeah, they are. It's just that the orbit has got a bit higher since we've done the plane change. Okay, yes, they're getting closer. This is a bit more about fiddling and trying to get used to that maneuver node, because that is your most important tool for any Kerbal in training. Another thing you can also do is move the maneuver node around a bit. This one, people don't think of straight off, because this can be quite important in that, look, see, we're getting closer, and we have an intercept. Now you could make do with this, you could check, you could do a lot of alterations. And oh yes, it's flashing on and off. I'm not sure if this is a bug in the game, or perhaps some of the mods I've got installed. You will see this the intercept flickering on and off later in the video. Don't worry about this if you have this, because as you get closer to Jool, it should either stop flickering or you can do course corrections to get a closer approach. And we'll be doing course corrections on this as well. But using the control panel or the automatic guidance system to point at our maneuver node, we set ourselves our course. And a quick fast forward in the video to do the burn, because I don't want you to watch all of this. Or am I going to make you watch all of this? Now perhaps I could take this time as we are doing this maneuver to ask you, what else are we going to do around the Jool system? This is the sort of introductory of the tutorials that I'm going to use for going to Jool and its many moons. Now there's a lot we can do. Someone suggested doing a space plane to Lathe, which is sort of like a Kerbal-sized planet, which has an oxygen atmosphere, so therefore you could use jet engines on that planet. However, it is mostly ocean and not much land, which makes it awkward to get to. Anyway, you can see that I've set this up inefficiently, and I've burnt a bit too much on here. Never fear. As long as you have enough fuel, you can always burn retrograde and correct it, or you can do course corrections on the way to Jool. So let's go ahead and fast forward and leave Kerbal behind, because what we have planned next is our correction burn. And this is quite the important part of the journey. Yes, getting your burn, I suppose, is quite important, but I suppose your correction burns are more important. And here we go, the flickering of the intercept markers. So anyway, as you can see, we are going to be passing Jool quite far away. So adding a correction burn halfway between Kerbal and Duna to make things easier. And also, if you focus view on the planet Jool, you will see the maneuver node on where, well, not the maneuver node, you will see the close approach that we have. And yes, this is flickering on off. If you have this, it seems to flicker on and off when you're adjusting it. Don't forget to use the radial as well to get yourself in the same plane. And there you go, showing you how much delta V this maneuver is going to take. Ooh, look at those moons. And let's get close. Right, a handy tip for you. If you want to use less delta V to get into orbit around Jool, get really close. And there's a good reason why I haven't added over 2000 meters per second for our orbit insertion burn, and that is because I want to use a highly elliptical orbit, and I'll show you why later in the video. Right, I'm trying to get this to go into the same plane as most of the moons, that way we can use that to our advantage to approach and fly by many of the moons. And don't forget, you can use the mouse wheel. If you hover the mouse over the marker, use the mouse wheel forward and backwards. Backwards seems to be your fine control. You can do as fine adjustments. And here we are trying to get close approach. That's quite good. Hopefully we don't intercept the moons on the way, but we'll get to that if we have to. Now, of course, this is the most important burn, so go ahead and use the Kerbal computer guidance system to get on the mark on maneuver node to ensure you get a perfect burn. But even then, it may not be 100% perfect, so I'm going to point to normal. And a handy tip here, and this is why I put RCS on here. Activate the RCS using the H and N keys, which are thrust forward and thrust back. You can see slight changes in the orange track as we're approaching Jool. So RCS makes things that the slightest adjustment easier to do, and that is why I put RCS on the probe. However, I find out I don't use it that much. A quick fast forward through time and space, as Kerbals are time lords too. We approach Jool. Now this will be a long and arduous journey. Let's hope you don't do this in real time. Now I have to note that you can see from the blue line that this is not the most efficient, and we seem to have lost our closest approach. But do not worry, my young Padawan. As you get closer to Jool, so will the force of gravity overtake. And you can see we're doing a fast forward, and as we get approach Jool, everything seems to be okay. We don't seem to be getting that glitching. If you do get keep on getting glitching with the orbits, then use quick save and quick load so you can do adjustments later on if you find that the orbits are in fact incorrect. Okay, so here I am setting the insertion burn, and I decide how high am I going to have it. Yeah, 2,200 million kilometers. Let's do a fast forward quickly to do our burn. And I have to note here, this is why I should have kept the other stage on the transfer burn, because it uses a lot of fuel to get into orbit. However, the closer you are to a planet, the more efficient you are, because you're using the effect, the all-birth effect. And in fact, what we're actually doing is we're using the planet's gravitational pull to pull us along while we're doing the burn, while it is orbiting the sun, and therefore pulling us along with it, increasing our orbital height in relation to the star, the sun, So that means we're traveling at the same speed, therefore we're more likely to orbit Jool. Jool, in fact, is the easiest planet to get into orbit around because of its large gravitational field. So guys, we're in orbit of Jool, and what you see here is the bonus footage. Yes, I said about doing flybys of the moons, and I'm targeting each moon, to see if we get an intercept. But don't forget, we may have to do multiple orbits, and that's why I'm warping in this instance, because yes, look at this. We have a close approach on which moon is this? I think this is Val. So all we have to do is add a maneuver at the highest point. If we can get ourselves there. And what we're going to do is add a maneuver at the periapsis, which is more efficient to do so. And I almost forgot, extend all these radiators and the communications to make it look a bit more proby. Now you can add mods to add cameras and stuff, but I'll leave all that to you. Okay, add a maneuver. I'm trying to use the RCS at the moment to get close approach. If you can't do that, add a maneuver. It's much easier if you do add a maneuver. It at least shows you how much delta V you require to get yourselves your intercept. Now, like with any maneuver node, you need to experiment, and hey presto, we got a close approach, and it's going to get us into a slightly lower orbit because of the pass. That's one thing you have to look out for, is the closer to the moon you pass, the more the gravitational pull of it is going to affect your orbit around Jool. It'll either throw you into Jool, or throw you out, or throw you into an unusual orbit that you'll never intercept another moon again. Now I have to warn you, tweaking to get your orbits correct can be a bit difficult, especially when you're dealing with multiple moons and multiple intercepts. But we've only got one intercept so far, and we're only getting to slightly lower orbit around Jool, so everything is fine. And ladies and gentlemen, we are now performing a flyby of Val. We're taking pictures and sending them back to Kerbal for prosperity and science. Okay, so what next? Well, while we're passing this moon, let's check to see if we have any flybys of any other moons. Bob, no, it's too far out of our orbital plane. They're the harder ones to get to, is the ones that you're not in the right inclination. Ooh, we have a close flyby of which moon is this? I think this is Tylo. So let's see what happens. No, prograde and retrograde don't work. As I said, tweaking. Ooh, yes, if we do radial burn, we will get a close approach of Tylo. Okay, so burn done. I'm not entirely sure if we do the burns close to the moons, if it's using the Olbeth effect to its great effect. But as you can see, now we're getting escape velocity from passing this moon, so from Tylo. So what I suggest you do, you can use a couple of things. I'm using the RCS to adjust our orbit so that we're not going to go and escape from Jool as we are by here. Okay, this may take a bit of time for you, but fiddle about, use maneuver nodes, use the RCS, and try your best. Okay, so we're going to hit Tylo if we carry on this, but what if we go to the other side? Ooh, a weird orbit. And now coming to this side, we're going to impact into Jool itself. Now this would be good if we wanted to do this. If we were to do an impactor for science, that would be fine, but it's too early in the mission for that. So I do a correction burn, get ourselves into the correct plane, and do a fast forward, and we get an accidental intercept with a lathe. And that is the center planet. Maybe the next planet, moon, I have to correct myself, moon that we're going to arrive to in the Jool system. It is in fact the most interesting moon or any body that you would get in the Kerbal solar system, because it can support Kerbal life. Now if you're going to build a colony, it would be there. I would point out things like there could be high radiation around Jool, which would prevent Kerbals from getting there, but they're glowing green anyway, so I don't think the extra radiation will matter them. But here you go, ladies and gentlemen, Lathe. Awesome planet. But first, before we go anywhere, before we go doing any science observation, we need to burn again, otherwise Lathe will boost us out of the Jool system. This can be a bit of a headache to manage this, especially if you decide to leave the probe in orbit, go and do another mission, you come back, and it's either flung it into a moon or into Jool, or out of the Jool system altogether. And that is a worry, especially if you've got other missions going and you have to go and check upon them. It's best to, if you have to, either put the probe in orbit around one of the moons, or around Jool, or in a very high orbit so it does not intercept any of the moons at all. That being said, I think this is the end of this tutorial, and the end of the fun that we have had. So now we will leave this probe in orbit, doing its maneuvers, doing flybys of all the moons, get into weird orbits, and maybe someday impacting the planet itself, as what they're going to do with the Cassini mission once it's completed its mission. So anyway guys, let me know what you want to do next in the Jool system, perhaps a lander for Kerbals, or something simple, because all I can say now is I'm Orbiter. Trust me, I'm an engineer.